Welcome, everybody. We are here at the final session, Tuesday of NAB at the Backblaze NAB Theater. With me is Ethan Steininger from Mixpeek. Mixpeek is an agentic solution for object storage. And Ethan's going to take us through what Mixpeek is and how it interacts with Backblaze B2. Very excited. So Ethan, please take it away.
Cool. Hey everyone, nice to meet you. My name is Ethan Steininger. I formerly led the search team at MongoDB, building out search. And what I had seen on the MongoDB team building search is every single customer that we were working with was building a custom index on top of object storage. And what this typically amounts to is custom models, custom pipelines, workflows, et cetera, for particular access patterns. And then the challenge was, as soon as the access patterns evolved beyond what they had originally built the index for, they had to rebuild the index from the ground up. And so I left Mongo building out Mixpeek, which is effectively the infrastructure to support the index lifecycle for queries as they evolve. And now that's effectively become agentic access patterns. So what we're going to do is talk through how agentic access patterns work and why object storage is the best substrate for the access patterns. And so Mixpeek is the name of the company, and I'll just walk through at a high level on how that works and how it interfaces with object storage. And so we're going to assume we have a high-level understanding of search, but at its core, we are at a media conference, and media tends to be very video-oriented. And if you think about the contents of a video, you can treat that as a table, right? Within a video, you have scenes. Within a scene, you have faces. Within a faces, you have expressions, right? So you can decompose these videos into an arbitrary number of layers. And then once you have all of these layers, think of them as their own standalone indexes. And so again, each of these indexes are stored on object storage, and they're typically composed of vectors, their payloads like metadata, JSON. They can even be scalar data structures, right? And so each of these layers represents different features that you would pull out of an object, in this case, a video, right? And so once we have the objects decomposed into their atomic units, well, then we can do very targeted types of queries, right? So if we wanted to search product demo with Sarah, okay, who is Sarah and what is a product demo, right? And so we would have to traverse each of these collections independently, right? So in this case, a product demo would traverse the vector search collection, which has the scenes. It would then take the results of that and then send it to the face collection, so on and so forth, until we get the most accurate data structure at the very bottom of this multi-stage retriever pipeline. So this is object reassembly. And so if you're a data scientist or an ML engineer, this is what you do, right? This is all a data scientist does all day. They build object decomposition pipelines, and they reassemble them on query time in order to surface the features that are most relevant for the application, right? And so we start with object decomposition, and that gives us the ability to traverse the different units that are pulled out from the object. So product demo with Sarah, again, we traverse all of those collections on query time, right? And so once we have the objects decomposed, and then we have the objects recomposed, then really the meat and potatoes of all of this is to be able to align it with your own internally maintained data structures. And so these are often taxonomies. And when we talk through a lot of these film companies, they typically have their own internally mapped taxonomies. And so if you think about what a taxonomy in the media world, you typically have, let's say, films have characters, characters have different kind of orientations, and so on and so forth. And so when you are able to decompose your videos, you align those videos and the atomic units to the taxonomies that you maintain, then you can ensure when you do your retrieval, you are only surfacing the features that are relevant to the taxonomies that you've aligned on retrieval time. And this is just like a flat taxonomy. We also have hierarchical taxonomies here. So again, this is what data scientists do all day. They feature extract from objects, they do reassembly, and then they align it to their internally maintained data structures, often hierarchical taxonomies. And so that is really what it comes down to is you're decomposing, you're reassembling, and then you're aligning to what you determine as truth in the in your data systems, right? And so if we go back to the home page, we could see what that really looks like. So if we're doing, let's say, IP detection, right, on the left-hand side, you have all of the different sources, you have the different feature extraction, and then you do the multi-stage retrieval. Similarly, if you wanted to say, hey, what are all of the different tastes that we have across visual configurations, then we would have that dedicated feature extraction pipeline, decompose the films, decompose the user ratings, align them using the retrievers, and then surface them to the clients, to the applications, and then ultimately, potentially, to the agents as well. And so what we're going to walk through is a demo application that has all of this mapped out within a UI, right? And so let's go to copyright.mixpeek.com. Right, and so this is a demo application powered by object storage, Backblaze B2 on the back end. And again, when you have these videos tend to be stored in object storage. And so what we're unlocking is the ability to also store the vectors and the metadata in object storage as well. And so nothing ever leaves object storage. And because Backblaze is part of the Bandwidth Alliance, there's no egress fees that are accrued by the customer as long as we're using a compute solution that doesn't leave the region, right? And so in this case, we have the ability to supply a video and automatically detect any copyright instances in that video. So in this case, we've maintained a bunch of collections. Those collections contain faces, they contain logos, they contain audio files, and all of these are copyright, trademark, patented trademarks, so that when we upload a video, we can ensure that the video doesn't contain any faces, doesn't contain any logos, and doesn't contain any audio files that are violations of trademark infringements. And so what this enables is really the full end-to-end video automation pipeline, so that you can say, hey, go from archive to production and ultimately serve the ad to production and have everything be as confident as possible, so that you don't have to think about any DMCA violations that you will accrue. And so if we look at, let's say, the Nike logo, again, it's running through these retriever stages, and then it's aligning it to the collection that we've maintained. So think of this as a join, right? We're taking this query, we're decomposing the image. The image is a query in this case. We're decomposing it into the bunch of layers, and then we're assigning them the comparison between the internally maintained data set. So this is that taxonomy capability that we talked about. And then what we can see is all of the reference indicators of, hey, this is a Nike brand trademark violation. And we have the full lineage of ensuring, hey, when a Nike swoosh is present in an image, in a video, we know exactly what it is referencing. And in this case, it has 84% similarity. But what's really powerful here is we can actually capture the approval or denial of this matching, and down the line, because we're capturing these interactions, we can fine-tune these models, and we can ensure that any kind of matching that we do later on is aligned to the progress that we capture from our human feedback loop, and ensure that we're more accurate as we go, right? And so this is an example that is traversing the logo collection. And again, each of these retrievers are those bespoke pipelines, and we can actually take a look at what they look like here. If we look at, let's see, product feature extractors, these feature extractor pipelines tend to be very custom combinations of models under the hood. And so if you are, actually, let's look at the docs. If you are a data scientist and you are building a face detection model, then you often have to do bounding box detection, you have to do alignment, you have to do embedding generation. Each of these are all standalone models in order to basically just spit out a bounding box, a landmark, a detection score, a face crop, et cetera, in addition to a 512 embedding dimension. And so this is really what we're capturing and storing under the hood, again, in object storage, because all of this is technically, it's just vectors, payload indexes, et cetera. And so because these feature extractors are mapped to those different collections, we can do retrieval to that collection when we do retrieval on access pattern time. Right? And so when we're providing the Nike image, we are traversing the logo retriever, which is saying, hey, given this collection ID, right? And this collection ID in this case is just a unique identifier, but it maps to the logo collection that we created, which is very tightly coupled to the logo feature extractor that we defined. And we could do the same thing with the face extractor, right? And so Brad Pitt, we have a celebrity in this image, and we want to know, hey, does this image contain any celebrity faces that are potential trademark violations? And again, if we have a video, that video contains a lot of different frames. We want to ensure that that video doesn't contain celebrity faces, logos, even United States Patent Trademark Office audio sounds, right? And so we can feel confident that if we were to actually publish this video, we can ensure that it doesn't contain any trademark violation. So this is a free product that we have that is built on top of the platform. And again, it is powered by object storage under the hood. So nothing ever leaves the underlying object storage. So it's payload in, right? In this case, it's an image, comes from object storage typically, goes through the processing, and then dumps right into object storage. And so if we look at what the payload actually produces, so this is the reference data set, the reference asset. That's typically the taxonomy that we maintain. And we can add to the taxonomy as we go, right? So that's what these libraries are. Each of these libraries are, in this case, faces, they are logos, and they are audio sounds. And so we can add to them as we go. Every time we introduce a new celebrity, we can add to this face collection. And so as we add more videos to our catalog, we can ensure that we are staying up to date with different celebrities. So, and the challenge with these generative models is they're often trained on data sets that are from the public domain. And so if we are publishing a video, we can ensure that any celebrity that is in that video is maybe even redacted, or we're snipping them out at the individual timestamp. And so this is really what powers those agentic workflows so that we can publish something that is fair use. And we also have like the alerts and analytics so that we could say, hey, what is our average block rate? And we can automatically send it to legal review if we need to, right? And so this is really just one use case on top of the object decomposition flow. And if we go back to the homepage, we can see other types of use cases. So again, we have all the different feature extractors. These are built, managed, and maintained by us, typically composed of state-of-the-art models, state-of-the-art pipelines, workflows, et cetera. And these are what decompose the objects. We have retrievers. These are multi-stage retrieval pipelines that allow you to assemble the objects that have been decomposed on retriever time. And then again, you basically just combine them all in creative ways to do the dataset versioning, anomaly detection, multimodal RAG is what most people here are familiar with. And this allows more granular capabilities. How did the product launch go? Okay, what is product launch? What is citation? What is timestamps? Those traverse the different layers in the decomposition flow that we created. And so again, nothing leaves object storage. And because we've built this serverless vector database on top of object storage, nothing ever leaves the underlying system where it's stored. And how it works under the hood is we have the client issues a query, the coordinator fans it out, sends it to the different shards. Shards then send it to the object storage, and then everything is sent right back to the client, right? And so nothing, again, leaves the underlying object storage from the source and the destination. And so this is really powerful because it means there's no egress fees, both from a compute and a storage standpoint. And because it's serverless, you don't have to pay for any idle use of the actual compute. And again, my name is Ethan, and I'm happy to talk through any use cases. Yeah.
Ethan, I think I think what you built here is a really fantastic, well-tailored platform for very specific use cases, very easy to sort of monetize, sort of in combination with Backblaze here. Really, thank you. Nicely done. Thank you for this. Very interesting stuff.
Thank you.